So today we are gonna discuss the questions of NEET 2025 question paper, chemistry part only. So the first question is the ratio of wavelength of light absorbed by a hydrogen atom when it undergoes n equal to 3 to n equal to 4 to 6 transition. We have to find the ratio of wavelength in two scenarios. So the formula of wavelength is 1 by lambda r 1 by n1 square minus 1 by n2 square. What happens is, in an atom, suppose electron revolves in different orbits. So when an electron jumps from a higher orbit to lower orbit, what it does, it releases energy because it becomes stable by coming nearer to the nucleus. So we can find the wavelength of the light emitted from this formula. So in this question we have to find the ratio of wavelength in one case when it's n equal to 2 to 3, when electron comes from the third orbit to the second orbit. In that case the wavelength is r 1 by 2 square minus 1 by 3 square. So it comes to be r 5 by 36. Second scenario, let us take it as lambda 1. So lambda 1 comes out to be 36 by 5r, and lambda 2 will be when r jumps from 4th to electron comes from 6th orbit to 4th orbit. So in that case the formula will be 1 by 4 square minus 1 by 6 square. It comes out to be r 1 by 16 minus 1 by 36. The LCM of 16 and 36 is 144. So it is 9 minus 4 by 144. That comes out to be r 5 by 144, or lambda 2 is 144 by 5r. This was 1 by lambda 2. We have to find the ratio of lambda 1 by lambda 2. So it is 36 by 5r divided by 144 by 5r. That is 36 by 144, and it comes out to be 1 by 4. Is there any option of 1/4? Yes, the option is option D. So the correct answer is option D. Next question is, which of the following statements are true? Unlike gallium that has very high melting point, cesium has very low melting point. Where does gallium exist as compared to cesium? So gallium exists in group 13, that is boron, aluminum, gallium, indium and thallium. Here it is gallium. And where does cesium exist? Cesium exists in group 1, lithium, sodium, potassium, rubidium, cesium. So we are comparing between gallium and cesium, their melting point. So what happens down the group? Down the group size increases. As size increases, the force of attraction increases, therefore melting point should increase. Therefore the melting point of cesium should be greater than that of gallium, since gallium has a higher size. So the first statement is incorrect, as cesium has a higher melting point. Next, on Pauling scale, electronegativity of nitrogen and chlorine are not the same. Nitrogen exists in group 15, nitrogen, oxygen, fluorine, neon. Chlorine exists below fluorine. So can nitrogen, fluorine have the same electronegativity? Electronegativity is the tendency of an electron to attract a pair of electrons towards itself in a bonded state. Since chlorine is in group 17, along the period electronegativity increases. Along the period electronegativity increases. Down the group it decreases. But since it is group 17. Fluorine has higher electronegativity, but it is also below. So I assume that B can be correct. Let's see the other option. Argon K plus Cl minus calcium 2 plus S2 minus are all isoelectronic species. In isoelectronic species, the number of electrons must be same. So argon has 18 electrons, K plus also has 18 electrons, Cl minus has 18 electrons, calcium 2 plus also has 18 electrons, S2 minus also has 18 electrons. So C is definitely correct. So the option in which C doesn't exist are incorrect. A is incorrect. The correct order of the also A is also incorrect. So option 4 also gets cancelled out. So it's between C and D and C and E. Correct order of first ionization enthalpy of correct order of first ionization enthalpy of sodium, magnesium, aluminum, silicon are, so the first ionization energy order, let in case of ionization enthalpy, it is better to write with electronic configurations. So we have sodium, magnesium, aluminum and silicon. Neon 3s1, neon 3s2, neon 3s2 3p1, neon 3s2 3p2. So ionization of sodium must be the least, and ionization of aluminum should also be less than magnesium. Why? Because it has full paired up electrons. So according to Hund's rule, the atoms having fulfilled orbitals are more stable. Therefore aluminum should be less than magnesium. So let's see the order. In the order, it is given in straight order, so it's incorrect. It is saying along the period ionization energy increases, but it's not the case according to electronic configuration. The atomic radius of cesium is greater than that of lithium and rubidium. Of course it is, because lithium, sodium, potassium, rubidium, cesium, it is group 1. Now the group size increases, therefore atomic radius of cesium is greater. C and D is definitely correct. C, D was wrong. So A, C, E. A I said is incorrect. So option 2 is correct only. Comes next, go to the next question. Match list 1 with list 2. List 1 is the ion. List 2 is the group number in cation analysis. Cation analysis is the qualitative analysis we do in the laboratory when we are given a sample and we have to find out the metals present. So there are different metals are divided into different group numbers. So if anyone has done practical, at least he must remember that aluminum is in group 3, so D must be in 2. So option in which D is in 2 is only option 2. So in that way I can get the answer. Otherwise you have to just remember a little of this table. The groups are divided from 0 to 6, 0, 1, 2, 3, 5, 6. Group 0 is NH4 plus. You can remember in this way that NH4 plus is not a metal, so it's given group 0. Aluminum was in group 3. It's not that difficult to remember aluminum because sodium, magnesium, aluminum. It's although it is in group 13, but in this way we can memorize it into being group 3. Similarly, magnesium is in group 6. You have to remember at least this. Also, it will be helpful in Viva. Next question is, predict the major product in the following sequence of reaction. First HBr is added, then KCN, then Na. So let's try. If HBr is added, we can see there is a peroxide. So if peroxide is added, it follows anti-Markovnikov rule. So this is a 3-degree carbon atom, this one, and this one is a 2-degree carbon atom. So according to anti-Markovnikov rule, it attached to the 2-degree. Anti-Markovnikov rule says that whenever there is a peroxide, the order of attacking will be 1, 2, 3. 1 degree greater than 2 degree greater than 3 degree. And if only HBr is added, then there is a reverse order. So Br gets attached to the 2-degree carbon atom. Then KCN is added. Anyone can say or even guess that when KCN is added, CN gets added in place of halogen. Next is Na. NaHgC2H5OH. So CH3, it becomes CH2NH2. It is reducing agent. It reduces into amine. So the option which matches is option 1. Also, suppose we do not know the last one, then also you can conclude from this state that 2 cannot be the answer, 4 cannot be the answer. And also NC forms when we add, I think, chloroform. So this also cannot be the option. By cancelling out the options, the probability of getting the answer increases. Suppose you have the doubt in only in these two, then you can think a little in the last moments, and there's a high probability of getting the right answer. Energy and radius of first Bohr orbit of helium plus and lithium plus are given. We have to find the answer. What is the energy and radius? So the formula of radius is R equal to A0 n square by Z. Energy is minus RH Z square by n square. The value of A0 is given 52.9. I am starting with helium. We have to find helium plus. Helium plus 52.9 first orbit. The mass of helium is, at Z is the atomic number is 2. So it comes out to be 26.45 picometer. So the option in which the radius of helium is 26.45, the radius of helium, so option 2 cancel outs. Option 3 can be correct. Option D is also wrong. So comparing option 1 and option 3, we can say that the radius of lithium is same in both, so we need not find the radius of lithium. We have to calculate the energy of Li2 plus. So let's see. Energy of Li2 plus minus RH Z square by n square minus RH is 2.18 10 to the power minus 18. It is given. Lithium's atomic number is 3, first orbit. So minus 2.18 into 10 to the power minus 18 into 9. It comes out to be approximately minus 19 point something 10 to the power minus 18 only. 9 2s are 18. So let's see. 10 to the power minus 18, option 1, it is 10 to the power minus 16. So option 3 is also not correct. Option 1 is the correct answer. The values are given of RH and A0. so we need not memorize it. Which of the following are paramagnetic? Of these, which are paramagnetic? Let's start. NiCl4 2 minus, so the charge of nickel comes out to be 2 plus. Let it be x, so x minus 4 equal to minus 2, x equal to plus 2, that is oxidation state is 2 plus. Oxidation number of nickel is argon 4s2 3d8, since nickel has atomic number of 28. Nickel 2 plus will have argon 3d8. Now what happens is, sorry. So nickel is 3d8, 1 2 3 4 5 6 7 8. So there is 3d, then there is 4s, then there is 4p. Now what happens after that depends on the ligand. If ligand is strong field, then pairing up occurs. If pairing up occurs, it becomes diamagnetic, that is strong field ligands give diamagnetic product. We have to find the paramagnetic. So as I have said, strong field ligands gives diamagnetic. So we know how many strong field ligands are there: CO, CN, EN and ammonia. Also there is PPS3. Only these 5 ligands are strong field. In this order itself, CO is the strongest, I think, then CN, then EN, then ammonia. So if it is a strong field ligand, what happens is, if this is strong field ligands, what happens is the electrons gets paired up. After that, the electrons of the remaining ligands enter and we get the hybridization. So strong field is CO, CN, EN and ammonia. EN is ethane 1,2-diamine. So CO is strong field, it is diamagnetic. CN is diamagnetic, PP3 diamagnetic. Answer is A and D. I hope it's clear. Given below are two statements. Like nitrogen that can form ammonia, arsenic can form arsine. Ammonia, nitrogen, phosphorus, arsenic, antimony, bismuth. This is group of 15. Nitrogen forms ammonia, arsenic should form AsS3. So if it is in the same group, it must have same oxidation state and it must definitely form this compound. So statement 1 is correct. Statement 2, antimony can form antimony pentoxide. Antimony Sb can form Sb2O5 pentoxide. So in here its oxidation is +5. So group 15 elements can show two oxidation state, +3 and +5. Why two oxidation state? Because phosphorus, suppose I am taking phosphorus, I could also have taken nitrogen, because neon 3s2 3p3. If 3p electrons are donated, it shows +3. If all are donated, it shows +5. So if both oxidation state are present, Sb2O5 can form +5. Definitely it can form. So statement 2 is also correct. Both statement 1 and 2 are correct. Option 1 is correct. Also one more thing is that down the group what happens, Uh, Suppose nitrogen, phosphorus, antimony shows plus 5 oxidation state or are stable in plus 5 oxidation state. Down the group it decreases to plus 3. That is nitrogen, phosphorus, arsenic, antimony, bismuth. They are stable in plus 5 oxidation state. Down the group it comes out to be plus 3 oxidation state. This phenomenon of decrease in 2 oxidation state is called inert pair effect. Why does it happen? Because as we go down the group, the addition of f orbitals comes. If you write the electronic configuration, you will see that there are f orbitals in between. So what happens? Since f orbitals are poor shielders, also d orbitals are also poor shielders, the size doesn't increase as compared to the number of protons which get added in the nucleus. Therefore the size doesn't increase much, therefore the tendency to lose electron also decreases. So if someone thinks in that way that Sb shouldn't form pentoxide, it should have formed Sb, suppose Sb2O3. So also it's also possible, but formation of plus 5 cannot be stopped, especially if oxygen is present, since it's too much electronegative. So therefore both the statements are correct. Which among the following electronic configuration belong to main group elements? So which are main group elements? Main group are S and P. S and P, the elements, that is S is group 1 to P is group 13 to 18. So any element which comes here are S block. So let's see, neon 3s1, definitely. Which element is this? Sodium. Sodium is S block. Next is B, argon 3d3 4s2, 3d3 unpaired, therefore it's D block element. Also, what is the atomic number? 18, 21, 23. 23 is scandium, titanium, vanadium. So B doesn't exist. Here we can see there is D10, but the thing is P is unpaired, so definitely. Let's see which atomic number it falls. Helium, neon, argon, krypton. Krypton is 36, then we have 46, 48, 53. 53 is just before xenon. Which noble gas is just before xenon? Fluorine, chlorine, bromine, I think. Sorry, bromine, iodine. Sorry, iodine, it's iodine. Iodine is a halogen. So A and C are definitely there. A and C, A and C. Option 3 and option 1 cancel out. Option D, argon 3d10 4s1. Which atomic number? 29, which is of nickel, nickel, copper. So D doesn't come, so option 2 is only correct. Option E we don't have to see because it is also F block element. We can see F or D, but from option only we can guess the correct answer. Time is also a major factor. Why waste in these silly questions? So suppose we are in doubt, the question was easy, but some questions become tricky. If we are doubt, we should know the process to derive our answer from two ways, just to be sure, because every marks matter. Dalton's atomic theory could not explain which of the following? Dalton's theory explained the law of conservation of mass, constant proportion, multiple proportion. It didn't say much about the gaseous volume, which was later explained by Avogadro. If you see the statements of Dalton, we will normally get the constant and multiple proportion. What does constant proportion say? A given chemical compound always consists of same proportion of element by weight. That is, if it is water, the ratio of hydrogen and oxygen should be always be 2 is to oxygen is 16, 1 is to 8 always. If it comes out to be something else, then the molecule isn't water, it is something else. Suppose in hydrogen peroxide it comes out to be 1:16. What did multiple proportion say? Multiple proportion said that when two or more elements combine to form more than one compound, suppose C plus O2 gives CO2, C plus O2 also gives CO. The ratio of one element which combines with the fixed mass of other element are in the ratio of small whole numbers. We need not say anything about law of conservation of mass, and law of gaseous volume was similar to the stoichiometry we learned. When gases combine, they do so in fixed ratio by volume. That is, if it is 1 mole, then the volume also will be 1 liter and 1 liter. Consider the following compounds: KO2, H2O2, H2SO4, oxidation state of the underlying elements. KO2, if you remember, Na, potassium, lithium, sodium, potassium, rubidium and cesium. Lithium forms oxide, that is Li2O. Sodium forms peroxide. This is from S block element, class 11th question. Class 11th, I think S block, yes. And sodium forms peroxide, potassium, rubidium, cesium forms superoxide. So the oxidation state in peroxide is +1. Why +1? We can normally only calculate Na2O2. Let it be x. So 2x minus 4 equal to 0. X equal to +1. Sorry, Na2O2, no? Oxidation state, then +2 it comes out to be. I have to check, sorry, cross check, I forgot. Na2O2, 2x minus 4 equal to 0, x equal to +2, it comes out to be +2. Is it possible? I don't think. It will come out to be +1 only. In KO2, the oxidation state is, so it exists as KO2 minus, that is K plus and O2 minus. So what happens here is, since O2 minus exists as one molecule, the oxidation state of K is +1. So in every option we can say there is +1 in option 1 and 3. Next comes H2O2. H2O2, we have to find the oxidation number of O2. So let's see, normally 2 plus 2x equal to 0, x equal to -1. So -1, there is only one option, +1, -1 and +6. Also sulfur is +6 in H2SO4, we can cross check that. So it was very easy question. 56. In the half-life for a first order reaction is 1 minute, then the time required for 99.9% of completion of the reaction is closest to half-life of first order reaction is 1 minute. T half is 1 minute. Then what comes? K 0.693 minute inverse. Time required for 99.9% completion. Time is 2.303 by K log R0 by R. For a reaction, reactant to product, the time of the reaction for a first order reaction is this: concentration of reactant by concentration of product. Now substituting the value of K, also it is said that for the reaction to complete 99.9%, half-life is 1 minute, then the time required for 99.9% of completion of reaction is closest to. So suppose the initial reactant was 100 gram. If 99.99% is completed, that is this much reactant has been finished, then what is the quantity of reactant now? R0 was the quantity of reactant initially, R is the quantity of reactant later. So if in 100 gram 99.9% have been reacted, the number of R left is 0.1. That is, initially it was 100. If 99.9% of R has been completed, R has reacted, then how much will remain? 0.1 only. So it comes out to be log 1000, that is log 10 cube. So log 10 cube comes out to be 3. That is 0.231. So from here I think we can say that 2.3, it is also 2.3 if 10 is multiplied from both sides. So this 10, so both cancel out, so answer is 10. Answer is 10 minutes. The correct order of wavelength of light absorbed by the following complexes. Wavelength of light absorbed. So what does wavelength depend? In a metal complex, the orbitals split up into T2G and EG in presence of ligands. Now the wavelength of light depends on the when electron jumps from higher orbit to lower, suppose wavelength of light is emitted. So this wavelength of light we have to arrange correct order of wavelength. So this wavelength will depend upon the difference here, that is the crystal field splitting energy. Now how is energy related to wavelength? We know that energy is hc by lambda. Now greater the energy, that is greater the energy required for electron to jump from T2G to EG, the lower will be the wavelength. So if energy is greater, that is CFSE is greater, then the wavelength is less. Now where does the CFSE depend? On whom does the CFSE depend? It depends on the ligand. If ligand is strong field, what happens? The CFSE is greater. What happens if CFSE is greater? The ligand gives low spin complex. We know this thing, that is, since the ligand is stronger, therefore it forms low spin complex. Why? Because CFSE is greater. So from here we can calculate, if ligand is stronger, then the wavelength must be less. Now stronger field ligands, I have already said, strong field ligands are CO, CN, EN, ammonia. So in these cases the wavelength will be less, because these are strong field ligands. These always form low spin complex. So CO, CN, and ammonia. So the order is also in this way: CO, CN, EN, and ammonia. So the order is also in this way. So CO is here, CO, CN. So B is the strongest. So B must be having the least wavelength. So B is having least wavelength in option 1 and option 3. Then is CO, CN, EN, and ammonia. In which option does ammonia exist? Option A. So after B it must have been A. So only one option is there. Greater the ligand field strength, lower will be the wavelength. Why? Because energy is inversely proportional to hc by lambda. Which of the following compounds can exist as cis trans isomer? Pent 1 cannot exist as cis trans isomer because both hydrogens are in same side. Methyl hex 2 methyl hex 2 so here also 2 methyl are in same side. 1 dimethyl cyclopropane, cyclopropane 1 dimethyl. So here also I don't think there is a way. 1 not, so option 4 must also only be the answer. Cyclohexane 1 dimethyl. So here I cannot show it's cis trans isomer, but if you have studied, cyclohexane normally exists in chair form, where 1 2 3 4 5 6 are carbon atoms. One CH3 is in this form, the other is in this form. Suppose it is it rotates. If it rotates in the opposite direction, what happens? This CH3 comes out like this and this comes out to be like this. So it exists as both cis and trans form. Phosphoric acid ionizes in 3 steps. Ionization constant K1, K2 and K3 respectively. What is the overall ionization constant? Which of the following are true? So phosphoric acid, if anyone doesn't know its formula, it's written in the question itself, H3PO4. It dissociates to H2PO4 minus plus H plus, again H2PO4 minus dissociates to HPO4 minus plus H plus. Dissociation constant being K1, K2, K3, the overall being suppose Ka. So the relation is Ka equal to Ka1 into Ka2 into Ka3, that is log Ka is equal to log Ka1 plus log Ka2 plus log Ka3. So let's see which. So option A is correct. Option 2 being H3PO4 is a stronger acid than H2PO4 minus HPO4 2 minus. So is H3PO4 stronger acid than these two? So acid strength depends upon its ability to lose H plus. So H3PO4 readily loses a H plus, but in case of H2PO4 it is already in -1 state. So in order to become more negative, it is more difficult to liberate H plus and become more negative. So it is a weaker acid. It is also more weaker acid, because if you are already in negative state, it is more difficult to become more negative. You have a tendency to accept H plus, but here you are donating. So H3PO4 is a stronger acid, correct. A and B is only correct. So option 2 cannot be correct. Option 3 cannot be correct. Let's say option C, Ka1 is greater than Ka2 greater than Ka3. Option D is definitely not correct. Ka1 greater than Ka2 greater than Ka3, definitely. Option B and C are indirectly the same thing. If H3PO4 is a stronger acid, the Ka1 value would be higher. Suppose it have Ka1 of 10 to the power minus 4, then Ka2 would be minus 6 and minus 8, means it would be definitely less. It's the same thing, it's written in statement and option C is written in notation. So A, B, C is correct and option 4 is correct. Question number 60. Which of the following reaction do not give benzene as product? Addition of soda lime. If you remember, soda lime is NaOH and calcium hydroxide. That is, it forms decarboxylation and CO2 eliminates. N-hexane MO2O3. Simple organic question from class 12th. So it also forms benzene. Option 3 also forms benzene. Red hot iron tube at 873 Kelvin of ethine. So option 4 is definitely the answer. Also, what happens when in a diazonium salt water is added? Water always gives OH. So the answer is phenol. If the molar conductivity of 0.05 mole per liter solution of monobasic weak acid is 90 Siemens centimeter square mole inverse, its extent of degree of dissociation will be. Degree of dissociation is alpha lambda by lambda naught. Also, lambda is kappa into 1000 by C. Kappa is the conductivity and C is the molarity. So also, lambda naught is given. So lambda naught of monobasic weak acid, suppose M plus and minus or signs are given, suppose MOH, so its lambda naught will be by adding these two terms 349.6 and 50.4, it comes out to be 400, and lambda is given to be 90 by 400, 90 by 4. What is 90 by 4? 0.9 by 4, 0.2, 0.225. There's one option 0.225, it is also close, so be careful. So that's all. Thank you. Thank you. There are still some questions remaining, and I will try to cover it in the next part. Thank you.